Salutations, my little triglets. We are embarking on a new adventure today. We are starting chapter 7. This is section 7.1, and it's the law of signs. So there's a new sheriff in town, and he's talking about the law of signs. So the law of signs is used to find parts of oblique, kind of a cool word, oblique triangles. That means it has no right angles, and the sides are all different. So oblique triangles, or I'm sorry, right triangles are, you've learned SOHCAHTOA. Okay, that's to solve right triangles. But oblique doesn't work with those SOHCAHTOA because they don't have a right angle. So somebody came up with a way to solve them, to find their different sides and angles without SOHCAHTOA. Now, if you want the derivation of this formula, it's on page 702, but it's fairly lengthy, so I don't want to go through it here. I am just going to give you the formula. It goes like this: sine of angle A over side A equals sine of angle B over side B, and you could also add C and C in there. Now the book actually has this upside down where the side A is on the top and the sine of A is on the bottom. It really doesn't matter which way you do it because it's all in proportion. Okay. For the law of signs, you can use it on or use it with angle angle side triangles and angle side angle triangles. Okay, you can't use it with side 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 or any others. Only angle angle side and angle side angle. So let's do an example. So here's our triangle. This is 63 degrees. We'll call that angle C. Side C is directly across from angle C. We're going to say that's 56. And then we have angle A is 46. Side A we don't know, angle B we don't know, and side B we don't know. So you see all the little a is across from big A, little b is across from big B, and it's always going to be true. All right, one thing we do know about triangles is A plus B plus C equals 180. All the angles add up to 180, so we can find angle B right off the bat by plugging in 46 plus B plus 63 equals 180. Subtract 46 and 63, so we get angle B to be 71 degrees. All right, now I'm going to plug that in as one that we found. However, you'd be wise to not use 71 to find the other ones unless it's absolutely necessary. Because what if you made a mistake in your subtraction and got 61? And then you use that to find another angle or another side or something, then that one would be off. So if you can avoid it, only use or don't use the new information, only use the given information. But looking at this triangle, we need to use B eventually. Right now I'm going to find side A. So that means I'm going to use sine of A, which is 46 over little a, and then I'm given 63 and 56, so I'm going to use that, sine of 63 over 56. And now you're just going to cross multiply these two, so 56 times the sine of 46, and then divide by the third one here, so sine of 63, and that will get you A. So if you do all that, I get about 45.2, let's say, inches, if that's what we're dealing with. Now, does that seem reasonable? Look at 63 and 56, and then compare 46 and now 45. So C is the biggest angle, or in this problem, in this part, 63 is bigger than 46. That means 56 should be bigger than 45, and it is. So it makes sense. Now we need to use the 71, so sine of 71 over little b equals the sine, and we'll use the c again, sine of 63 over 56. Again, cross multiply, so 56 times sine of 71, divide by that third one, and that'll get you b. So little b, I got to be about 59.4. Okay, and again, 71 is the biggest angle, so 59.4 should be the biggest side, and it is. So they all make sense. They all are proportional. Okay, so that's when you have, um, go back here, that's when you have angle, angle, side, or angle, side, angle. Let's talk about the ambiguous case, and that is when you have side, side, angle. You learned in geometry that that is not a proper way to prove two triangles are congruent. You cannot use side, side, angle. If you look at it backwards, it spells that bad word. So this is a case that's going to change a little bit. So what happens in the ambiguous case here is if we're given angle A, angle B, and angle C, and I'm given little b and little c and angle A. A lot of different things can happen. I can have this side A only reach to right here, and this would have no triangle. It doesn't connect. Okay, so if we don't know what angle C is and what angle B is, or what side A is, there's no way to tell how it fits. Another different scenario, given A, B, and little c, is it could hit exactly straight down and you'd have one solution, and that would be at a right angle. There's a third scenario that could happen with this information, is the line side A would be longer than the height of that triangle, so it could swing left or right and actually make two different triangles. So I could have one looking like that, or I could have one looking like that. So I could have two different triangles. I could have that skinny one, or I could have the wide one here. Okay, so these are three different scenarios that could happen when you have side-side angle given to you. Okay, so, and actually you're given a, or side A. These are all side A's that are given here. So you have side, side, angle in that order. C is the one we don't know yet. So let's do an example of each of those. All right, let's see which one this one is. So angle A is 43 degrees, little a is 81, and little b is 62. Okay, so let's start off by using the law of sines, because I have 3 out of the 4 pieces here. I could find angle B by using the law of sines. So sine of 43 over 81 equals the sine of B over 62. So I'm going to cross multiply, so 62 times sine of 43 over 81, and that's going to be equal to the sine of B. So if I work all this out, I get 0.5220 equals the sine of B. Well, I don't want the sine of B, I want B. So you have to do the inverse sine of 0.522, and that will get you angle B. So I get angle B to be 31. Okay, so angle B is 31. If sine, right here, let's go back to this. If sine is positive, remember your unit circle, sine is positive in the first and second quadrants. So 31 degrees is right here. The other one is 31 up from 180. So 180 minus 31 is 149. Now, if it's 149, let's put that in parentheses. B equals 149, and we'll put a question mark. Think about that. If I now wanted to find angle C, I would have to take angle A and one of the angle B's away from 180 to find angle C. Well, if I add 149 and 43, that's above 180. So you can't have two angles that add to more than 180. So this one is not going to be the two solutions. Okay, it's not going to be this case here. All right, it's going to be a one solution where it hits it exactly once. And it doesn't have to be a right angle. Sometimes it is, but it doesn't have to be. Okay, whoops, I gotta go forward here. All right, so angle C, I can use the first B that I found. So 43 and 31 is 74. Subtract that from 180, and I get 106. All right, and now I can use the law of sines again to get little c. So sine of 106 over little c, and then I would use the two given, the a and the capital A. So sine of 43 over 81. Cross multiply those two, so I get 81 times the sine of 106, and then divide by the sine of 43, and I get approximately 114.2. So little c is 114.2. And it makes sense that little c is bigger because 106 is the biggest angle, so it should have the biggest side with it. Okay, so let's try another one. Let's see what happens in this next one. Let's say I have angle A equals 75 degrees. Little a is 51, little b is 71. So first thing we do is try to find angle B. So sine of angle B over 71 is sine of 75 over 51. Cross multiply 71 times sine of 75, divide by that third one. All of that I get 1.34 equaling the sine of B. Now if you try to do the inverse sine of 1.34, you get an error, because remember, sine and cosine cannot be above 1. On the graph, when we graph sine and cosine, it never went above 1 or below -1. So if you get 1.34, that's an error. That's no solution. So this one is where the triangle never quite hits, and we just say no solution. All right, next one. Angle A is 40, little a is 54, little b is 62. So let's try to find capital B here, angle B. So I'm going to do sine of A, sine of 40 over 54, sine of B over 62. Cross multiply 62 times sine of 40 and divide by the third one, and that'll get me sine of B. I get, when I work all that out, I get 0.7380. Okay, 7380. If I do inverse sine of 7380, I get about 48 degrees. Okay, now think about your circle. 48's about here, the other one's here. Just take 180 minus 48, and I get 132. Now think of adding 132 with my original 40 to get angle C. And it's only 172, which is under 180. So this is the case where we're going to have two solutions. So B1 and B2. So B1 is 48, B2 is 132. And then we have to find C1, C2, and little c1 and little c2. So it basically becomes a split problem here. So to find capital C, I'm going to just take 40 and 48, which is 88, subtract that from 180, and I get 92. So angle C is 92. Then I'm going to take that 92 and do law of sines in order to find little c. So sine of 92 over little c is sine of, go back, 40 over 54. So cross multiply these two and divide by sine of 40. And I work that out to be approximately 84 for that little c. Now I'm going to change to blue here because we're going to do C2 and little c2. So again, I have 132 and 40, that's 172, so angle C would be 8 degrees. And then I do sine of 8 over little c, and then sine of 40 over 54. So cross multiply, work that out, I got little c to be 11.7. And it makes sense. This is a big angle with a big side. This is a little angle with a little side. All right, so they're all working there. So that's when you have two solutions. So when you get that first angle B, subtract it from 180. If you get the combination is less than 180, then you got two solutions. All right, one more idea here. I know we're going kind of long, but there's a lot to talk about. We're going to talk about the area of an oblique triangle. Okay, we can't use, the old way was 1/2 base times height. That was if you had a right triangle, because base and height were right. Otherwise, you'd have to drop a height and figure it out from there. Well, somebody figured out that we can do trig in here and use 1/2 a times b times the sine of angle c. All right, so if you're given those, you can plug those in. Now, that's not the only version. I could have two other sides like B, C, and then I'd have to use sine of A. Or I could have 1/2 AC and then I'd have to use B. But regardless, A, B, and C are represented in all three of these. So this works when you have side, angle, side. And you can plug those things in. So for example, if I know this is 12 and these two sides are 8 and 2, I just say 1/2 8 2, or yeah, and then sine of 12. So you work all that out, and I get approximately 1.7. And then that's square meters or meters squared or whatever it is. Make sure you're putting squared on there. Okay. Then I'm going to do one more problem, and it's a story problem. We've got lookout stations out in the forest. They have stations to look for fires, and they are 20 miles apart. So we'll have Station A and Station B, and we know they're 20 miles apart. Someone notices a fire up on the mountain, so we're going to draw it way up high here. I'll draw my little fire going on up here, and they spot a fire, and from A, they notice it has a bearing of north 50 east. Now you have to think about that. You have to start headed north, and then you have to go east, and that angle is right here. That's 50. Okay, and from B, they notice it's going north 36 west. So go north from B and then go west, and that angle out here is 36. It's not the inside angle, it's the outside one. But we can find the inside angle because now I've made a 90 degrees. So this angle is 40 and this angle is 54. Now given those, the question I want to know is how far is the fire from A? Okay, how far are we from A to get to that fire? So what we need to do is find this distance. Okay, that's basically it's little b because it's across from angle B. So what do we need? Well, We need angle B, which we have is 54, so the sine of 54 over B. And then we need to have two other sides, or another side and another angle. Well, I have this angle, but I don't know its side. I have this side, but I don't know its angle. But we can figure out this angle up here, we'll call it angle C, by subtracting 180 minus 40 and minus 54. So angle C, I got to be 86. So C is 86. So now I can say sine of 86 over 20. Okay, cross multiply, divide by sine of 86, and I get x to be about 16.2 miles. Okay. All right, that is it for now. Ta-ta. And don't forget, Trig love is all around. And this problem, Trig love, is burning hot. All right, see ya in class.